Hello, everyone. Thanks for joining us for another installment of our AMS webinar series. This month, we're covering 5-axis machining, which is a very interesting topic, and I think you guys will find it very informing. My name is Don LaCourse. I'm a senior application engineer here with MecSoft, and I'm joined also by Joe Anand. Joe is MecSoft's product manager. And I'll be going over the presentation slides, and Joe will be handling the actual 5-axis demonstrations. Joe, we want to go to the next slide? Okay, a few housekeeping tips here. If you've been with us regularly, you know a lot of this already. If you have questions during the webinar, there's a window in your GoToWebinar dialog for entering questions. And you can enter questions at any time. I'll be monitoring the questions in the background, and I will bring them up during the webinar, and we'll see if we can't get them answered. If for some reason we run out of time and we can't get your questions answered, we'll make sure to contact you directly with the answers. Also, a recording of this webinar is being made as we speak, and we'll make this available to you in a couple of days after we clean it up and get it ready to publish. Okay, Joe? Now, our agenda today. Everything today is talking about 5-axis machining. So initially, we're going to start out by talking about the different coordinate systems in CAM, and also the multi-axis machine setup, which is a very important topic for setting up your CAM parts to work with your specific 5-axis machine. Next, we're going to be talking about the different types of control geometry that you will come into in 5-axis machining. Drive surfaces, drive curves, check surfaces, all of the geometry types we'll be covering today. Also, we're going to talk a little bit about 4-axis continuous machining methods, and then also 5-axis continuous machining methods. In our product in 5-axis, you can output in 4-axis mode, so that you might be wondering why we're talking about 4-axis continuous methods. Also, we'll be talking about how to machine a mesh in 5-axis, which the process and procedure is different for mesh geometry versus NURB surface geometry. And then finally, we're going to talk about machine tool simulations. We're not going to actually set one up, but we have one set up in one of our slides, and we're going to show you how that works. And then also, we're going to talk about post-processing in 5-axis mode. Now, what are the benefits of 5-axis? Why should you get a 5-axis configuration from MecSoft CAM? Well, the primary reason is that you can machine complex geometry that you may not be able to machine on your 3-axis machine. Okay, if you have areas of the part that you can only get to from a 5-axis orientation, then obviously you're going to want a 5-axis machine because you won't be able to cut those on a 3-axis machine. Also, using a 5-axis machine, you can increase your accuracy of your machining only because there's less setups. You don't have to move the part around. Like I mentioned in item 1, you can get at all of your orientations of your features of the part using 5-axis. And then also, cutting, there's a lot of advantages for your cutting tools. You can extend your tool life by having a constant chip load. By machining in 5-axis, you can access the features, and using your tool to access the features, you can set up a constant cutting condition. And then also, you can get a better finish by using shorter tools, less deflection on the tools by using a shorter tool, and reducing tool and machine vibration. Okay, Joe? Now, the first thing we want to talk about is the different coordinate systems in a 5-axis machine. And what you see here on the left, you have a typical 3-axis setup where you have X, Y, and Z meaning the three primary axes and 3-axis. In the middle, you have a 4-axis setup. In addition to the 3 axes, you have the additional 4th axis rotation axis. And then on the right, you see a typical 5-axis setup. In the image that you see on the right, we're showing a head-head configuration where the 4th and 5th axis reside in the head of the machine tool. Now, when you get to 5-axis, there's 3 different configurations of 5-axis that you can set up your machine for. And all of them relates to where the axes are located on your particular machine. So on the left, we have a typical head-head configuration where the 4th and 5th axis are located in the head of the machine. And then in the middle, the table head configuration, you have the 4th axis on the table and the 5th axis on the head. And then on the right, you have a table-table configuration where both the 4th and the 5th axis reside on the table, and the spindle of the machine is doing the cutting. Now, this slide is actually relatively important, and Joe's going to go over a little bit more detail in an actual part. But on a 5-axis machine, you need to pay attention to what the gauge length is on your 5-axis head. And if you look at the illustration there on the right, you'll see that the gauge length is measured from the face of the spindle to the rotary axis on the head. So that's the gauge length that you may need to enter in your CAM file in order to get your 5-axis machine tool setup running correctly. Next slide, Joe. Okay, we have this slide here just so you know that you can run 5-axis in an indexed orientation, meaning that you can index your 5-axis machine to access any side of the part that you can get to in a 5-axis setup. And in this example, we have this part being machined from 3 sides, the right, the left, and the top. And there's an example machining job there in the middle where you can index your 5-axis machine at each one of these setups, lock it in place, and perform 2- and 3-axis machining operations. Okay. Now, in this example, we've got a number of examples in these slides we're going to show you, and that illustrates some of the key features. Now, you can perform 5-axis continuous flow curve machining in 4-axis mode. And we mentioned this earlier about using a 4-axis. Why were we talking about 4-axis? Well, in the example you see here on the right, you have a 4-axis part, but you have a surface that you can use 5-axis continual flow curve machining and output that in 4-axis mode. And then also you can use 5-axis continuous machining to machine complex injection mold blocks, core molds, cavity molds. In this example, we have a core mold that we're using 5-axis continuous between 2 curves machining, 5-axis continuous swarf machining, and then also a 3-axis offset pocket machining. And then the machining job in the middle illustrates how the mold machining operations are set up. Now, next we have a rotary instance, 4th-axis rotary instance example, where you can combine 5-axis machining with your rotary axis. So in the example on the right, you see we use continuous swarf machining, continuous surface machining, continuous curve projection machining. These are all to machine one instance of the rotary blade that you see. And then also you can implement your 4th-axis rotary instance to rotate that and then perform those 5-axis operations on each of the blades in the setup. Now we're going to talk about how to machine meshes in 5-axis. Mesh geometry can be relatively complex, and many of the mesh parts that you may have to machine can only be machined in 4 or 5-axis mode, just simply because of the complexity of the geometry. So you can set up a mesh to machine in 5-axis using 5-axis continuous methods. Next slide, Joe. And finally, we're going to talk about how you can set up for advanced machine tool simulation. In this example, we're simulating our mold example and on a 5-axis machine, as you can see here on the right.